Examples on linear algebra. First example, give an example of non-zero 2 by 2 matrix A such that A square is equal to A. So what is meant by zero matrix? A zero matrix means all the entries of the given matrix is equal to 0. For example, 0 0 0, this is what? A zero matrix. If any one of these entries non-zero, then it is called non-zero matrix. So if we consider matrix A is equal to here 1 0 0 1, then A square is equal to A into A, so it is equal to 1 0 0 1 into 1001, and it is equal to, since it is an identity matrix, its multiplication is again 1001, and which is equal to what? A. And therefore A square is equal to A for A is equal to 1001. Second example, solve the following system of linear equation: x minus y plus z. Again here y and z are free variables, so put y is equal to t and z is equal to r, where t and r are real numbers. Then this implies x is equal to y minus z, and this implies x is equal to y is what? Y is nothing but the t, and z is what? R. So x is equal to t minus r, y is equal to t, and z is equal to what? R. And therefore this is the solution of the given this system, x minus y plus z equal to 0. And therefore you can write here x is equal to t minus r, y is equal to t, and z is equal to r, where t and r are real numbers. Next example, let w is equal to xy, where x plus y equal to 0 is w subspace of R square. So w contains, and some I am writing here some element, say I'm going to write here, okay, some element here, say 0 5, then 5 0, then 3 2, okay, then minus 10 5. These all elements are lie in w, minus 10 5, not 10 minus 5, sorry, 10 minus 5, because their addition is equal to what? 5. But if we select a, say w1 bar is equal to 0 5, and w2 bar is equal to say 3 2, then w1 bar plus w2 bar is equal to 0 5 plus 3 2 is equal to 3 7, and the 3 plus 7, this vector does not belong to w. Why? Because 3 plus 7 is equal to 8, not equal to 5, and therefore w, the set w, subset w is not closed under vector addition, and therefore, and this implies it is not, it is w is not subspace. Therefore w is not subspace of R square. Next example, now we want to justify whether the set S is equal to 1 0 0 1 is linearly independent subset in R square. So given vector, we say v1 bar is equal to 1 1, and v2 bar is equal to 1 0 0 1, Now I want to check whether these two vectors are dependent or linearly independent. So if we consider matrix here, say 1 1 and 0 1, the matrix, if we consider determinant of this matrix A, consider this matrix A is equal to 1 1 0 1, then determinant of A is equal to 1 1 0 1 is equal to 1, which is not equal to 0, and therefore the set S is equal to 1 1 0 1 is linearly independent. Next example, if A is 4 by 5 matrix and row rank is equal to A, then what is column rank? As we know that the row rank of matrix A is same as column rank of matrix A, and therefore column rank of A is equal to what? 3. So this is the answer here. Column rank is equal to 3. Next example, if T is a mapping from V to W is a linear transformation. Next example, let T is a mapping from V to W is a linear transformation. Prove that T of minus U bar is equal to minus T of U bar. So what is given here? Given T is a mapping from V to W is linear transformation. Now then as we know that minus 1 into U bar is equal to minus U bar, and therefore if we apply T on both sides, then T of minus 1 into U bar is equal to T of minus U bar. But what is T of minus 1 U bar? Since T is a linear transformation, we can write this as minus 1 into T of U bar, but is equal to T of minus U bar. But what is minus, if we multiply minus 1 into vector, it is what? Minus T U bar is equal to T of minus U bar, and therefore T of U bar, from this we can write minus U bar is equal to minus T of U bar. Because why we write this? Because T is what? A linear transformation. We can write here, since T is a linear transformation. Next example, let given S is a basis for R square, and we want to determine what is the coordinate vector of U bar here. If U bar is given 1 4, so we are going to write here U bar is equal to alpha 1 times minus 1 0 plus beta times 1 2. So here if we simplify here, U bar is what? 1 4, and this is equal to minus alpha plus beta, and this is equal to 0 plus 2 beta, so this is equal to 2 beta. So if we simplify here, if we equate the LHS and RHS, then we get minus alpha plus beta is equal to 1 and 2 beta is equal to 4. From this, beta is equal to 2, and this implies alpha is equal to, now beta is 2, then alpha is what? Minus 1. Alpha is what? If we put here minus alpha, my plus 2 is equal to 1, then alpha is what? 1. Sorry, not minus 1, it is alpha is 1. So alpha is equal to, alpha is 1 and beta is equal to what? 2 here. So what is the coordinate vector here? U bar S. The U bar S is equal to coordinate vector u bar relative to the basis S is equal to alpha beta, which is equal to alpha is 1, beta is what, 2. So this is the answer here. Next example, for which value of k does the following system have unique solution. So if we write this matrix into a system form, then this system into a matrix form, we get 2 1 1 k into xy equal to 0 0. Now if we multiply 1 by 2 into r1, we get here 1 1 by 2 1 k. Okay, and then if we use the row operation here, r2 minus r1, then we get 1 1 by 2 1 and k minus 1 by 2, sorry, here 0 0 into xy is equal to 0 0. Now for unique solution, we want this entry should be non-zero for unique solution. Okay, sorry, for unique solution, otherwise we get infinitely many solutions. Since it is a homogeneous system, for unique solution we want k minus 1 by 2 is not equal to 0. This implies k is not equal to 1 by 2. So for k is not equal to 1 by 2, then we get this unique solution. So this is the answer here. Next example, let V is equal to R cube and be a vector space, and W is equal to XYZ such that X is 0 or Y is 0, be a subset of V, is W subspace of V. So if you write a few element of W, W contain either X is equal to 0 or Y is equal to 0. So if we consider here 0 1 2 or 1 0 2, okay, or say 0 2 3 or 2 0 5, such elements lie in set W. So we want to check whether it is subspace. So if we select here W1 bar is equal to 0 1 2 and W2 bar is equal to 1 0 2, then W1 bar and W2 bar both vector lie in the set W. But if we take their addition, W1 bar plus W2 bar, then we get here 1 1 4, and which does not belong to W. Why? Because not X is 0 or Y is 0, and therefore W is not closed under vector addition, and therefore W is not subspace of V. Next example, okay, if A is a matrix of order 5 by 3 and B is a matrix of order 3 by 2, then what is the maximum possible value of rank of AB? So we want to determine what is the maximum possible value of rank of AB. So here order of matrix A is 5 by 3 and order of matrix B is equal to 3 by 2. So the order of the matrix AB is equal to 5 by 2. As we know that the rank of AB, rank of AB plus nullity of AB is equal to 2. So we want the maximum possible value of rank of AB. So if nullity is 0, then rank of AB is equal to what? Maximum possible value of rank of AB is what? 2. Maximum value we get is what? 2. So the next example, the solution space want to determine, find the solution space of the system of linear equation x minus y z y minus z plus 2 equal to 0. So put y is equal to t, since y is a free variable, z is equal to r, where t and r lie in they are real number, and therefore we get x is equal to what, t minus z, so minus r plus 2, and therefore what is here solution? X is equal to t minus r plus 2, y is equal to t, and z is equal to r is the solution of the this is the solution space of the system of linear equation x minus y x y minus z plus 2, or in other words you can write this as, if we write this as x y z, then we get it is equal to t minus r plus 2, t and r is the solution space, or in other words you can write this as t 0 plus minus r 0 r plus 2 0 0. So this is this is the solution space of the given system. Next example, for which value of alpha the vector v is equal to 1 minus 2 alpha is a linear combination of u bar and w bar. So now we want to express this vector v bar as a linear combination of, say, k of u bar, k1 of u bar plus k2 of w bar, w bar. So what is v bar here? V bar is 1 minus 2 alpha is equal to k1 times u bar is equal to 3 0 minus 2 plus k2 is equal to 2 minus 1 minus 5. So now if we equate the LHS and RHS, we get here 1 minus 2 alpha equal to 3 k1 plus twice k2, then minus k2, then minus twice k1 minus 5 k2 equal to what? If we equate the LHS and RHS, then we get thrice k1 plus twice k2 is equal to 1, minus k2 is equal to minus 2, and minus 2 k1 minus 5 k2 is equal to alpha. So if we simplify here, then we get k2 is equal to, if we simplify here from this equation we get k2 is equal to 2. If k2 is 2, then k1 is what? 3k1 plus 4 is equal to 1. This implies 3k1 is equal to minus 3, and this implies k1 is equal to minus 1. So k1 is equal to minus 1. If we substitute this two value here, then we get the value of alpha. So alpha is what? Minus 2k1 minus 5k2. So this implies alpha is equal to minus 2k1. k1 is equal to minus 1, and minus 5k2, minus 5 into 2. So alpha is equal to 2 minus 10. So this implies alpha is equal to minus 8. So this is the value of alpha. For that, if we have alpha is 8, then we can express this vector as a linear combination of u bar and w bar. The next